Water is a unique substance with many important properties that make it essential for life and has many applications in science and industry. Some of the key properties of water are: polarity. Water is a polar molecule, meaning that it has a positive end and a negative end. This polarity allows water molecules to attract and interact with other polar molecules, such as other water molecules or ions in solution. Cohesion and adhesion. Water molecules are attracted to each other through hydrogen bonding, which creates strong cohesive forces between water molecules. Water also exhibits adhesion, meaning that it can stick to other surfaces. This is why water droplets can form on surfaces, and why water can move up through narrow tubes against the force of gravity. High surface tension. The cohesive forces between water molecules also create a high surface tension, which allows small objects, such as insects or paper clips, to float on the surface of the water without sinking. High heat capacity. Water has a high heat capacity, meaning that it can absorb and store large amounts of heat without undergoing a significant temperature change. This property makes water an effective coolant in many industrial processes and also helps to regulate the temperature of the Earth's oceans and atmosphere. The high heat of vaporization. Water has a high heat of vaporization, meaning that it requires a large amount of energy to evaporate. This property makes water an effective coolant in many industrial applications and also helps to regulate the temperature of the Earth's atmosphere. Expansion upon freezing. Unlike most substances, water expands when it freezes. This is because the hydrogen bonds between water molecules become more rigid and create a lattice structure. This property is important for the survival of aquatic organisms, as it allows ice to form on the surface of bodies of water, insulating the water below and preventing it from freezing completely. Solvent properties. Water is a versatile solvent, meaning that it can dissolve many different types of substances, including polar and ionic compounds. This property is important for many biological and chemical processes, as it allows molecules to interact and react with each other in solution. High surface area. Water has a high surface area compared to its volume, which is important for many biological processes. For example, the surface area of water in the lungs allows for efficient gas exchange during respiration. Transparency. Pure water is transparent, allowing light to pass through it. This property is important for many aquatic organisms that rely on sunlight for photosynthesis, as well as for optical applications such as lenses and prisms. pH neutrality. Pure water has a neutral pH of 7, meaning that it is neither acidic nor basic. This property is important for many biological and chemical processes that require a stable pH environment. Lubrication. Water can act as a lubricant in many biological and industrial applications. For example, the synovial fluid in our joints contains water and acts as a lubricant to reduce friction between bones during movement. Density. Water has a relatively high density compared to other liquids, which is important for many oceanographic and atmospheric processes. For example, the density of ocean water determines the formation of ocean currents, while the density of air affects the formation of weather patterns. Specific heat. Water has a high specific heat, which means that it requires a large amount of energy to raise its temperature. This property helps regulate the temperature of the Earth's climate, as large bodies of water can absorb and store large amounts of heat energy without undergoing large temperature changes. Thermal conductivity. Water has a relatively low thermal conductivity compared to metals and other materials, which means that it does not conduct heat as efficiently. However, this property makes water an effective insulator in some applications, such as in double-paned windows or insulation for buildings. Surface charge. Water molecules can become ionized, meaning that they gain or lose electrons and become charged. This property is important for many biological processes, such as the transmission of nerve signals, and for chemical reactions that involve charged particles. Hydrophobicity. Some substances, such as oil, do not mix well with water and are considered hydrophobic. This property is important for many industrial applications, such as separating oil from water and oil spills, and for biological processes, such as the formation of lipid bilayers and cell membranes. Dissociation. Water can dissociate into its constituent ions, hydrogen ions, H+, and hydroxide ions, O, which is important for many biological and chemical processes, such as acid-base reactions.